Hello, everyone. Welcome to my presentation. Thank you to Fabian for the interesting paper and also introducing reuse, and thank you to the conference chairs and then for the editors for this, for setting up this presentation or this conference. So my presentation today is going to be on using engraved QR codes to connect building components to materials passports for circular construction. I'd also like to thank the co-authors helping this paper, but so I'm a doctoral student at ETH Zurich, and I'm in this chair for circular engineering for architecture, and we're broadly looking at different digitalization techniques for circular construction. So to start maybe with a bit of intro on what is circular construction, I'd like to draw on the analogy of Legos, a nostalgic childhood toy that a lot of us played with, where we bought the box, it came with a set of instructions and with the little Lego blocks, and then we built something. After a couple of weeks, maybe we got bored of it, and then we tore it down, and we combined it with other Lego blocks, and we built something new. This is kind of the premise behind circular construction. So how can we build something that's a bit more modular, that we can take it apart and rebuild it in the future? To do this, to scale up from Lego blocks to buildings, we have to think a little bit about the information transfer. Blocks are pretty simple, there's not too much going on, but with the steel beam, you have more issues such as strength or deformation over time. So that's kind of the premise behind circular construction. To move into what is a material passport and how we should be thinking about it, I want to draw also from other industries that we can learn from. The first being the consumer goods or consumer products industry. So from here, if you think about every time you go to a grocery store and you buy some strawberries, there's a lot of steps that happen to get those strawberries into your hands. It starts at the farmer. The farmer has to pick the strawberries, put them in a basket, put it on a pallet board. The pallet board goes in a truck, the truck to a warehouse, to another truck, to the grocery store, and then it's scanned with the barcode at the cash register. There's a lot of steps in the supply chain, and so how do we ensure continuity over that? The consumer products industry has already done a pretty good job with this barcode. For instance, if the farmer finds that there's E. coli or some bacteria on their crop, they can go all the way down the supply chain and extract the strawberries and the lettuce from the grocery store. So I think there's a lot to be learned from that industry. We can also think how people are tracked. Each of us have a unique set of fingerprints, right? This is our biological identity. And this is coupled with things like our government ID. Becomes important for things if I go to one doctor and I want to transfer information to another doctor. That sort of continuity of information is pretty important. As well, when I got in the airport at Zurich, I had my face scanned, and that allowed me to get into the airplane. So things like facial tracking is also becoming a good way to track people, and as we start traveling more and more. And this is kind of documented in a normal passport. So how do we extend this to the building industry? Well, again, we can kind of think about a steel beam. For me, when I was working on a job site, the steel beams would come in, and they would have a few numbers written on the steel beam, which hopefully correlated to a procurement document, or at best correlated to a design document. So this is pretty good in this stage, but if you think maybe 20, 30 years from now, they're going to do some renovations, they're going to open up the wall, and they'll see these numbers, and what do those numbers correlate to? Hopefully they still have the design documents, but perhaps not. So how can we think of different tracking technologies to associate on our beams or on our other products, and so in future use cases, we can still extract important information. So this kind of goes into the focus of this paper, where there are three big things we wanted to look at. The first was exploring different tracking technologies. The next was developing a proof of concept for applying the tracking tech. And then lastly, we wanted to utilize real materials and on a real project. So you can see in this image on the right, it's a neatly packed set of wood beams that we're able to actually recover from a job site. Earlier this year, in about January, our lab went from Zurich to Geneva, where there was a factory that was about to be demolished. We had basically 2 or 3 days to extract as many materials as we could, load it up on a truck and a van, and take it back to Zurich to play around and experiment with new techniques. Part of the issue was, unsurprisingly, there were no design documents or any documentation at all, so we had to just visually inspect what do we think we could reuse. Being a car factory, and in Switzerland, a lot of it's made of concrete. But fortunately, on the third floor, there was some light frame construction that we figured there was wood underneath, and so we were able to deconstruct part of those materials. Back in Zurich, a colleague worked on a design algorithm for matching this stock to the new stock, and we were designing a geodesic dome using these linear wooden elements that was about 6 meters in diameter. So the point of my research in this is that I wanted to figure out how we can track each of these components, so when we deconstruct it, and potentially reconstruct it in the future, we have that continuity of information. So one of the things that we want to think about in construction is how do we move from something that is project-based and siloed to something that's process-based and can be implemented over time. So this was the set of criteria that we were looking at from a qualitative perspective. Just to briefly go over them, there are some of the obvious ones like reduction of human error, line of sight range. We also looked at two-way communication and location tracking, as well as ease of application and relative cost of implementation. So barcode, hopefully we're all pretty familiar with, but it contains data in one dimension. It's a relatively easy technology that's been proved multiple times over, but also a low-tech approach. We looked at quick response or QR codes, and these also are a relatively familiar technology. Pretty easy to apply, pretty cheap solution, but also doesn't have too much, it's not too technologically robust. Then we go into RFID or radio frequency identification. This is what we see a bit more in the literature these days in our industry for tracking components, especially through supply chain, because part of the advantage that they bring is location tracking with what's called the active RFID. Active RFID basically just means you have the power source embedded in the chip. The disadvantage of that is that over time the power source can drain, the battery can run out, and maybe you lose access to this information. Another technology is Bluetooth Low Energy, or BLE. This is the most technologically robust tracking solution with two-way communication and also real-time location tracking, but it's a bit more difficult to implement and also a high cost of implementation. And the last technology we looked at was NFC, or near-field communication. And this is the same sort of technology that we have on our cell phones if you have your credit card and you want to pay with your phone at a cash register. So also technologically a bit more complicated and a bit more expensive to implement as well, but a possible solution moving forward. For us, we were mainly interested in using the quick response codes because we wanted a solution that was scalable, that was easy to access and pretty cheap and easily modifiable. So we went with QR codes. Once you choose your tracking tech, you also have to think about how is it actually going to be associated or attached to the member that you're interested in tracking. So with QR codes, there are about 3 categories of ways we could think of for how we could apply the QR code. The first is with a printed tag, essentially. This is also a low-tech solution, relatively cheap. Some issues with this is that, as you could perhaps imagine, tags can be scraped off, especially if you're stacking a lot of the members together, so not super durable. One level up in durability would be a more permanent engraved solution, like on a metal tag or this plastic trolace material. And so this could stand the weather such as rain a bit more than a paper tag, but you still have additional hardware requirements such as screwing it in. The advantage of being able to screw in a tag means that in the future you could remove it and then add a different tag on the same component. The third component that we looked at, or third approach we looked at, was laser engraving. And the advantage of laser engraving is that it is embedded into the material, so you don't have to worry about the tag or the tracking technology falling off. But some of the disadvantages of engraving are you going to modify the material in the future, such as a really thick layer of paint over the QR code, which could affect it. Ultimately, the solution that we looked into was for the engraving of the QR code. This we found wasn't explored too much in literature or in practice yet, but we know is also transferable to steel beams as well. And quite frankly, we have several architects in our group, and we thought it was kind of aesthetic. So if you're engraving a QR code, there are different variables you need to consider. If you remember in the beginning, I mentioned there were no design documents, so we didn't know exactly what the material was. You could probably intuit that it's a soft pine wood, but we still had to fine-tune the parameters of how we wanted to engrave the QR code in. With the Trotec machine that we had, the 2 big parameters were both power and speed. So you can see on the left side where we kind of played around with these parameters. But we also wanted to explore if you were engraving on something such as the knot of the wood or on a chipped piece of wood, would that affect how readable it was? On the far right, it was a unique idiosyncrasy of working with wood, where if you recall, wood is made up of several rings that expand outwards as the tree grows. So with that, in each ring, there's a harder part of the wood and a softer part of the wood. And if you use a consistent power of the laser engraver, you're going to dig deeper into the softer wood than the harder wood. So that kind of produced these striations on the bottom right there, especially if you have the light hitting the striations in a certain way. this prevented it from being readable. So eventually we fine-tuned the parameters where we should apply the QR code. We also found a nice light sanding at the end, kind of helped increase the contrast, which was most important for quick response codes. So I won't go into too much depth here, as it's a bit beyond the scope of the paper. This was the concept of the material passport that we used. So each of the linear elements, there were about 160 in the project, took you to a unique material passport that had some basic information on location, the geometric properties or material properties. And this was very important for us because unfortunately the final project you see on the right side, we couldn't keep that erected in the Bauhalle forever, so we had to take it down. But fortunately, we knew of some students at a different university that were interested in the process of reuse, so we were able to deconstruct it, ship it to this other city, give them the original design drawings, and then they were able to match that with the QR codes of the individual components to make sure the components aligned with rebuilding the structure. So it is still in use today in a different location. I think they're using it for, I think they have a radio station there now. So in the spirit of circularity, still moving forward with that. So the method strengths of using QR codes, and kind of as mentioned, that it is cheap and accessible. It is pretty easy to scale up. You can use some simple Python code or an Excel code even, as well as the storage is pretty easy. So if you use a third-party QR code manager, pretty easy to kind of manipulate it later on or just review which ones you've already produced. The method weaknesses, as perhaps you could also intuit, are the visibility or line of sight range. So if you're thinking about, we're using linear wood elements here. If you have a stick frame construction building, the wood is hidden behind some gypsum board or some other covering. So how are you supposed to get access to that wood without some sort of destructive entry into the wall? So that's where radio frequency technologies can better come into play, perhaps depending on the application or the type of component that you're interested in tracking. And then the last big weakness of this method in this material passport in general is data maintenance. So we also need to start thinking a bit more about who is going to be hosting the data over multiple life cycles and who is also responsible for maintaining the data, such as the condition of the wood. And this is hopefully where we want to continue our research into applying a bit of blockchain material passport technology. So to recap, the things that we looked at in this paper were what other tracking technologies can we use for our building components. We ended up on QR codes because of their ease of scalability. For applying the QR codes, we used laser engraving as a more permanent solution. Then we actually had to build the project, the fun hands-on part. And then lastly, verified it with some quality control checks, and as well as actually using the product information and rebuilding the dome. So as we aim to move towards a circular economy, we hope to supplement this process-based model for construction by integrating better tracking technologies, and with these tracking technologies, connecting to information at the product level. Thank you very much.